Okay, so we're going to use that formula for a right endpoint approximation to write the summation for a right endpoint approximation of the area under f of x equals x squared on the interval 1 to 3. So this is going to be the right endpoint approximation, and I should point out this is with n subintervals. That's the whole point of doing this with as a summation, because we don't actually know how many subintervals there are. We can't just write them all out, so we have to write it as a summation. Anyway, that's why we're doing this. So it really becomes just a matter of simply identifying the three things that can actually change here, which are f, we can have a different function, and we could also have a different starting and ending endpoint, b and a. So the three things you really have to identify, as complicated as this formula looks, really all you need to do is identify three things in order to use it. So the first thing to recognize is that f of x equals x squared. The second thing is that a equals 1, and the third thing is that b equals 3. Okay, so these are the only three things that could be different in any one of these problems like this. So we can do is we want to calculate the length of the subinterval, which is of course just going to be b minus a, and that's going to be b minus a, which is equal to 3 minus 1, or 2. So the length of the subinterval is just 2, and we're going to be able to use that in the formula. So I can, having done that, there's really nothing more to do other than write out the area is approximately equal to the sum from k equals 1 to n of, I'm going to replace I'm going to replace f with x squared, because that's the function that I'm given. So this is going to be a is 1 plus k times b minus a is 2 over n, and then times, oh sorry, and that's squared, and that's going to be 2 over n. So just to be clear where this maps onto, let me actually use different colors to indicate it. So this here is the green part, and this here is the red part of the equation, and then we're done. So this is the expression in summation notation for the right endpoint approximation of the area under that function on the interval 1, 3. So I'm a big believer in the idea that you don't really understand how to do a problem until you can solve it in reverse. So instead of just being given a function in an interval and plugging it into the formula, let's see if we can take a summation and interpret it as the area, as the right endpoint approximation of the area under a particular function. So the real question is to find the function in the interval. So we have here the problem to interpret the following summation as the right endpoint approximation of the area under some function on some interval. We're being asked to find the function and the interval. So here, let's just look at the formula for the area. What we can see is that we have, let's start with b minus a over n and see if we can find that in the problem. We certainly can. It certainly looks like this is going to be b minus a over n, and so is this. This is b minus a over n, because that's exactly how they appear in the formula. So it looks like that means that 7 is going to equal b minus a. Recall that b minus a is just the length of the interval, so we're talking about an interval that is, it's going to be of length 7. We just need to know where it starts. We'll notice that a appears in the formula here, and we can see that that's there, so I'm going to say that that's a. So if a is equal to 7, it means that 7 is equal to b minus 5, and that means that b is equal to 7 plus 5, or 12. So this interval is going to be the interval from 5 to 12, having a length of 7. It sort of makes more sense rather than the algebra if you just think about how it starts. I'm going to start the interval at 5, and I'm taking an interval of length 7, so it makes sense just to reason out that if an interval starts at 5 and has a length of 7, that means that its right endpoint must be 12. So that gives us that the interval is 5 to 12 in this problem. Now, what's the function? We see that the f in the formula wraps a plus k times b minus a over n. So that means that this is really going to be f of x. It's the sine squared function, because that's the thing that we're plugging a plus k times b minus a over n into. So that means the function is going to be f of x equals sine squared of x. So here's the information we need to answer the question. And the interpretation is this is the right endpoint approximation of f of x equals sine squared x on the interval 5, 12 with n subintervals. That's the interpretation of that summation, like that.